Okay, we'll continue with example 2. And example 2, it says calculate the surface area of the following pyramids. Here, the pyramids, their vertical heights are given, but the slant height is not given. And because of that, we don't know the height of each of the triangle that make up the faces of the pyramid. So we need to calculate the height of those triangles before we can do anything. To do that, let me start with A. For A, I have the height, the vertical height to be 19 inches. So to get the height of the faces of the pyramid, let me join a line like this, and then also draw a line down like this. That will give me the height of this triangle here. That make up the face, one of the faces of the pyramid. And this triangle here is exactly the same triangle here, this side here. This triangle and this triangle are exactly the same. So to get the height of those triangles, I'm going to apply Pythagoras theorem to this triangle here that I drew here now. So if I bring it out, I'll have something like this. I think I should use white here so that I can show clearly how this 19 inches, and then the base of this triangle is equal to the half of the length of the base of the pyramid, which is 18 inches here. So half of 18 is 9, and then base is what we're looking for. Let me call it x. So if I put in this into Pythagoras theorem, x squared is equal to 19 squared plus 9 squared. 19 squared is 361, and 9 squared is 81. 361 plus 81. Need a calculator here. I'll get one. 361 plus 81. That is 442. So x squared is 442. The square root of 442 will be 21 approximately. So the height of this triangle is 21 inches approximately. And remember that this triangle, whose height we just calculated, this one here and this one here, are exactly the same. So the next thing now is to calculate the height of the triangle facing front. This one right here in front, and the one at the back. The one in front and the one at the back are exactly the same. So to do that, let me draw a line back there. Yes, something like that, which will give us another triangle just like the one we just calculated. So let's use Pythagoras again to get the height. So to get the height of that triangle, there's going to be a line down here to complete this triangle. So with that, I will have something like this. The vertical height, which is 19 inches. Then this line going backward, this line here, this one, that is half of 12 inches. That is half of the width of the base of the pyramid. The width of the base is 12 inches. Half of 12 inches is 6 inches. And this height here is what we're looking for. The way I drew this in, to avoid confusion, let me extend this a little. Let me remove this and redraw it. I have 19 inches as the vertical height of the triangle. Then this base of this triangle is the base right here, which is half of this 12 inches here, and that will be 6 inches. So x, or let me call it y, since I've used x here already. Let me call this one y. Y, again apply Pythagoras. Y square is 19 square plus 6 square, which is 361 plus 36. 361 plus 36 is 397 also. 397. And y, the square root will be square root of 397 square root of 397 is 19.9. Let me round it up to 20 inches approximately. So the height of the front and back triangle is 19 inches because they are exactly the same triangle. Okay, now let's get the area of the surface area of the pyramid. To get the surface area of the pyramid, we calculate the area of the rectangular base and the area of the 4 triangles, add up everything together to get the surface area of the pyramid. So let's start with the area of the base. Area of the base. The base is a rectangle, so the area will be length times width or length times breadth. The length there is 18 inches and the breadth is 12 inches. 18 times 12, 18 times 12, 216. 216 inches square. The area of this base, rectangular base. The area of the 4 triangles. Okay, let's do the 2 triangles first. The triangle on the left hand side and on the right hand side. Let me call this left. And let me call this right. The area of left and right triangles will be 2 times half base times height. The area of triangle is half base times height, and there are 2 of them. That is why we have to multiply by 2 there. And that would be 2 times, let me continue here, 2 times half times the base of the triangle is 12 inches. 12. The height is what we calculated earlier, x, which is 21 times 21. These 2 can even cancel this. So that will have only 12 times 21. 12 times 21. 252 inches. 252 inches squared. That is the area of the left and the right triangle. Now let's calculate area of the front and back triangle. Area of front and back triangles. Again, front and back triangle are exactly the same. So 2 multiplied by half base times height. These 2 can cancel these 2. So let's just multiply the base and the height of the triangle. And that will be, the base is 18 inches. The height is what we calculated here, which is 20 inches approximately. So 18 times 20. 18 times 20 is 18 times 20 is 360. 360 inches square. Therefore, the surface area of this pyramid, SA of the pyramid will be the area of the rectangular base, which is 216 plus the area of the left and right triangle, which is 252, and the area of the front and back triangle, which is 360. Let's put all of this into calculator. 252 plus 216 plus 360 give us 828 inches squared. So the surface area of this pyramid is 828 inches squared. That is that for question A. For question B, let me copy this and move it down. Like it's not copied. Okay, that is that. Again, for B, we don't know the height of the triangular faces that make up the pyramid. So we are going to use the same logic we use in question A. Let me start with this triangle here. This one, the left and right triangle. Okay, this one is more visible. So if I draw a line here and then draw another one here, which form the height of this triangle. This line here is the height of the triangle, and to get that we apply Pythagoras theorem. Let me redraw the triangle here. I have the white color will be better here. I have this base of the triangle, which forms half of the length of the base of the pyramid. Half of 10 here is 5, so 5 feet right there. And then the vertical height, which is given here, 18 feet. 8 feet, not 18 feet rather. This slant height, which form the height of this triangle, is what we are looking for. Let me call it h. So using Pythagoras, h will be 8 squared plus 5 squared, which is 64 plus 25. 64 plus 25 is 89. 89. So this is supposed to be 8 squared. So h will be square root of 89. And square root of 89 is 9.4 approximately. 9.4 feet. That is the height of left and right triangle. This is left triangle and this is right triangle. Both of them are exactly the same. Now to get the height of the front and back triangle, again if I draw a line like this, it will form the base. The height of this front facing triangle should be, unfortunately there's no way I can draw this here. When I drop another line here, I will have something like this. The vertical height, which is 8 feet, and then the base of the triangle, which is half of 4, half of this 4 here, and half of 4 is 2. This height is what we're looking for, which is this line I was trying to draw with dotted line. Let me call that A. Again, applying Pythagoras theorem, a squared is equal to 8 squared plus 2 squared, which is 64 plus 4. And 64 plus 4 is 68. Then the square root of 68 will be square root of 68 is 8.2 approximately, which is the height of the front and back triangle. Now that we know the height of front and back triangle, we can calculate the surface area of this pyramid. Remember, surface area is the area of the rectangular base plus the area of the four triangular faces. So let's start with area of rectangular base. Let me call it base area. Base area is equal to length times breadth. That is area of rectangle. The length is 10 feet. The breadth is 4 feet. 10 times 4 is 40. With 40 feet square, it was the area of the rectangular base. Now, area of left and right triangle. Area of left and right triangles will be 2 times half times base times height. 2, because the two of them are the same. These two can actually cancel this, so I'm left with only base times height. And the base of this triangle, left and right triangle, is 4 feet. It's right there. So that is 4 times the height that we calculated earlier, which was 9.4 feet. 9.4 feet. And 4 times 9.4. I'll give 4 times 9.4. It was 37.6. 37.6 feet square is the surface area of left and right triangle. And let's get the surface area of front and back triangle. Area of front and back triangles again will be 2 multiplied by half times base times height. And these two can cancel this, so we are left with base times height. What is the base of the front and back triangle? The base is 10 feet. The height is what we calculated, which is 8.2. So 10 times 8.2 is 82 feet square. So we know the area of all the faces that make up this pyramid. Let's add them up to form the surface area of this pyramid. So surface area of the pyramid will be area of the rectangular base, which is 40 feet square, plus area of the left and right triangle, which is 37.6 feet square. 37.6, and area of front and back triangle, which is 82 feet square. Let's plug in all these values into calculator. 37.6 plus 40 plus 82. That is 159.6. 159.6 feet square is the surface area of this pyramid. Let's move on to the last question, which is C. Let me copy this down again. I'll move this one down. Okay, for the last one, again we apply the same method we have been using to get the height of the triangular faces. So if I draw a line here, down here, and then draw another line down of like this. That is the height. This line here is the height of this triangular face, and this triangle here and the one right here are exactly the same. So let's use Pythagoras to get the height. Let me reproduce the triangle here. Have this, this, and this. So this line at the base here is half of 14, which is 7. 13 inches is the vertical height, 13 yards rather. This height is what we need. Let's call it B. Applying Pythagoras, B squared is equal to 13 squared plus 7 squared. That is 169 plus 49. 169 plus 49 is 218. 218. That means B is square root of 218. Sorry, that is supposed to be 218. Square root of 218, which is 14.8 approximately. The height of left and right triangle, let me call this left and I call this right. Left and right triangle is 14.8 yard. Now let's get the area, the height of front and back triangle. For the front and back triangle, let me draw a line back there. And then the line, this dotted one here, we form the height of that triangle. So if I reproduce the triangle here, I'm going to have something like this. The vertical height, which is, change the color of that marker. Red will be okay there. The vertical height, which is 13 yard, and then this line going back here, mean this very line here, is half of 6 yard, which is 3. And then this line here is the height of this triangle. Let's call it C. So C square, applying Pythagoras, is 13 square plus 3 square, which is 169 plus 9. And 169 plus 9 is 178. The square root of 178 will give us the height of this triangle. The square root of 178 is 13.3 approximately. 13.3 is the height of front and back triangle. But now that we know the area of all the triangular faces, we can get the surface area of the pyramid, starting with the area of the rectangular base. So let's call it base area. Base area is area of a rectangle is of course length times breadth, and that will be 14 times 6, which is 14 times 6 is 84 yards square. And area of left and right triangular faces is 2 times half times base times height. That will be, these two can cancel these two. So I'm left with only base times height. The base of left and right triangle is 6 yards. 6 multiplied by the height, which we calculated earlier. The height is 14.8 yard. 14.8. 6 times 14.8. 6 times 14.8 is 88.8. 88.8 yards square. That is the area of the left and right faces of the pyramid. Then area of the front and back faces. Area of front and back triangles is equal to 2 multiplied by half times base times height. And these two can cancel these two, so I'm left with only base times height. The base of the front and back triangle is 14 yard rather. 14 multiplied by the height. The height is what we calculated earlier, which is C, and it's 13.3 approximately. 13.3. 14 times 13.3 times 13.3 is 186.2. So we have known the area of all the faces of the pyramid. Let's add them up to get the area of the surface area of the pyramid. The surface area of the pyramid SA is equal to the area of the rectangular base, which is 84, plus the area of the front, the left and right triangles, which is 88.8, and the area of the front and back triangle, which is 186.2. 186.2. Let's plug all of that into calculator. 84 plus 88.8 plus 186.2. That gives us 359. 359 yard square as the surface area of this pyramid. And that brings us to the end of example 2. Let's move on to example 3. For example 3, I have this. Let me zoom out, or zoom in rather, so we can see the diagram clearly. Okay, so again, for this pyramid, here the vertical heights are not given, but we have the slant height. So how can we get the height of the triangular faces of the pyramid? First of all, we need to know the vertical height. And to know this vertical height, we need to know the base here. I need to know this line here. Let me draw a diagonal. That is not perfect enough, but I'm going to manage it. Okay, I think this is okay now. To know the length of this diagonal, I will apply Pythagoras theorem again. So let me start. Let me call this A. Let me call this B. And let me call this C. So A, I'll have something like this. This base here, which is 18 inches. And then this, which is 12 inches. This line here, let's call it X. X squared is equal to 18 squared plus 12 squared. 18 squared is 324. 324 plus 144. 324 plus 144 is 468. 468. S therefore is square root of 468. And square root of 468 is 21.6 approximately. So the length of this line is 21.6. Now half of that will give us, let me use a different color there. I'm trying to get this place here. This length of this line here. With this length of this line, I can calculate the vertical height of this pyramid. And to do that, half of this line that we just calculated, which is 21.6, half of it is this painted one in red. So let me call that let me call it B. So B is equal to 21.6 divided by 2, which is 10.8 approximately. 10.8 is this painted line here. So with that, we can get the value of this vertical height, which is A in this case. So A square, using Pythagoras, A square is equal to this slant height, which is 12 inches, 12 inches square, minus this side here, which is 10.8 inches, 10.8 inches squared. And 12 square is 144, minus 10.8 square is 10.8 square is 117, 117, and 144 minus that is 27. So A is square root of 27, which is square root of 27 is 5.2 approximately, 5.2 inches. Okay, now that we know the vertical height of the pyramid, we can now calculate the height of the faces of the pyramid. Let me remove all these previous drawings so you can get a better explanation. Now, to get the height of each of the triangular faces, I'm going to draw a line here, and then this line down here will give us the height of left and right triangle. So let's do that right here. Applying Pythagoras, let me draw this triangle. This is A, and A is 5.2, 5.2. This is the base here, which is half of 18, half of this line, that is 9. And then this is what we are looking for. Let's call it X. X squared is equal to 5.2 squared plus 9 squared. And 5.2 squared will be, so it's square root of 27 is what gives us 5.2. Then 5.2 squared will be 27. 27 plus 81, that is 9 squared. 27 plus 81 plus 81 is 108. 108. X therefore will be square root of 108. And square root of 108 is 10.4 approximately. So height of left and right triangle is 10.4. Okay, now that we know the height of left and right triangle, let's use the same logic to calculate the height of front and back triangle. The height of front and back triangle will be something. If I draw a line back there, and that line is half of 12 inches, then if I drop another line from this top down to meet this line, that will be the height of back and front triangle, because they are exactly the same. So let's do that right away. Let me see if I can redraw that here. A, and A is, what was A? A is, where is it again? I thought I calculated A somewhere. Okay, I did not call it A there, it was 21 point. No, it's not. See A here. A is 5.2. A is 5.2. 5.2. 5.2. And then this line is half of 12 inches. This baseline here. And half of 12 is 6. This is what I'm looking for here. Oh, what a wonderful drawing that I drew there. The height of front and back triangle, let me call it F. So F will be the A, which is 5.2 squared plus 6 squared. And that would be 5.2 squared is 27 plus 36. 27 plus 36, that would be 63 also. 27 plus 36 is 63. And square root of this is supposed to be F squared. Square root of 63 is 7.9. So F is square root of 63, which is 7.9. So the face, the back and front faces of the triangle, their height is 7.9. So with that, let's get the surface area of the pyramid. Starting with area of the rectangular base. Area of base is length times breadth. The length of the rectangle is 18 inches, the breadth is 12 inches. So 18 times 12, 18 times 12. That is 216, 216. I think the value is, the unit is inches, inches square. Now area of left and right triangular faces, left and right triangle is 2 times half times base times height. These two can cancel each other. The base of the left and right triangles is what? 12 inches. Their height is what I calculated somewhere here, which is x is right here, 10.4. So 12 times 10.4, 12 times 10.4. 12 times 10.4 is 124.8. 124.8 inches square as the area of the front and left and right triangle. And let's get area of front and back triangle. Area of front and back triangle is again 2 times half times base times height, which give us 2 times, okay, these two can cancel. So let's just pick the base and the height. The base is the base is 18 inches. So 18 times the height, we calculated it to be 7.9 approximately. 7.9. 18 times 7.9 give us 142.2. 142.2 inches square. So we've known the area of all the faces that make up the pyramid. This is the base, this is the left and right triangle, and this is the front and back triangle. So surface area of this pyramid will be area of the base, which is 216, plus area of left and right triangle, which is 124.8, plus area of front and back triangle, which is 142.2. Let's plug all of that into calculator. 142.2 plus 124.8 plus 216. That is 483. So the surface area of this pyramid is 483 inches square. That is that. Let's do the other questions. Let's question B. Let me copy this and move it down. You can see it to work with. Okay, for question B, again, we use the same method we use for question A to get the height of the triangular faces. So first of all, I'll draw a diagonal of this pyramid here, the base of the pyramid. Half of this diagonal will give us the length of this triangle here. That will help us to get the area of the get the height rather of the triangular faces. So if we apply Pythagoras here, remember this is 4 feet here, this 2 is 4 feet here. So I'll have a triangle like this. Let me do it here. The base, which is 10 feet. This one right here, this line, which is 4 feet. And then this is the diagonal we are looking for. Let me call it D for diagonal. So D square is 10 square plus 4 square, which is 100 plus 16, which is 116. D will be square root of 116. Square root of 116 is 10.8 approximately. 10.8. Okay, now that we know the diagonal, half of the diagonal will give us, let me paint it with a different, I want to get this height here. So apply Pythagoras to this triangle right here. Let's draw the triangle. I have the height, which is x, which is what we're looking for. The slant height, which is given there 6 feet. And then the base, which is half of this 10.8 here. 10.8 divided by 2, that should be 5.4 by 2, 5.4. Here is 5.4. Why this slant height here is 6? This one right here. So s squared is equal to 6 squared minus 5.4 squared. And 6 squared is 36 minus 5.4 squared is 29. And 36 minus 29 is 7. So this is 7. S therefore is square root of 7. Square root of 7 should be 2 point something. 2.6 approximately. So the height of this triangle, of this pyramid rather, the vertical height is 2.6. Now that we know the vertical height, we can calculate the height of the triangular faces. How can we do that? If I drop a line from this point down here, this line there, and I do the same thing here, down there. This line right here is the height of this triangle here. And this triangle here, this left triangle and this right triangle are exactly the same. So with that, let me use a different color so that don't make mistake there. So this triangle right here and this is what we want to calculate. So F, let me draw it here. I have something like this, and then like this. This one here is half of this base, which is half of 10 is 5. So here is 5. Here is what we are looking for. Let's call it, let me call it A. Hope I've not used A anywhere before. So then we already know X to be 2.6. So here is 2.6. So A squared is 5 squared plus 2.6 squared, which is 25, plus 2.6 squared is 7. 25 plus 7 is 32. So A will be square root of 32. Square root of 32 is 5.6 approximately. So height of left and right triangle is 5.6. To get the height of front and back triangle, if I draw a line here and another one to meet it, this dotted line is the height of the front and back triangle. And then to get that, again we apply Pythagoras theorem. The vertical height which is x is 2.6. The base of that triangle is half of this 4 feet here, which is 2. And then this is the side we are looking for. Let me call it B. And B squared is equal to 2.6 squared plus 2 squared. And 2.6 squared is 7. So square root of 7 gives us 2.6. So 7 plus 4 is 11. B therefore will be square root of 11. And square root of 11 is 3.3 approximately. So we know the area, the faces rather. The height of the faces of the pyramid. We can now get the surface area of the pyramid, starting with area of the base plus area of the 4 triangles. Area of the base is, the base is a rectangle, so the area is length times breadth. The length is 10 feet, the breadth is 4 feet. 10 times 4 is 40. Area of right, left and right triangle. Area of left and right triangle is half times base times height, then multiply by 2, the 2 of the triangles. These 2 can cancel these 2 here. So I'm left with only base times height. The base of the triangles is 4 feet. The base is 4 feet. I have 4. The height, we calculated it earlier. The height of the triangle, this height here is 5.6. 5.6. 5.6, or 4 times 5.6 is 22.4. 22.4. And then lastly, area of front and back triangle, this triangle and the one behind. Area of front and back triangles is half times base times height multiplied by 2. These two can cancel these two. So I'm left with only base times height. The base of the triangles in front and back is 10 feet. 10 feet. The height is right here, which is 3.3. So 10 times 3.3 is 33. Therefore, surface area of the pyramid is area of the base plus area of right and left triangle plus area of front and back triangle. The base is 40. I have 40 plus 22.4 plus 33. 40 plus 22.4 plus 33 is 95.4. 95.4. What was the unit? The unit is feet. Feet square. So feet square. That is the surface area of that pyramid. Now for the last one, let's copy it again and move it down so we can work on it. Let's paste it here. Okay. So to get the height of the triangular faces, let's first of all get the base of the diagonal of this pyramid. This diagonal here. And apply Pythagoras. That would be this 14 here. This is it. This is here. This is it. And this side D. D square is equal to 14 square plus C square, which is 14 square is 196 plus 36. 196 plus 36 is 232. 232. So D will be square root of 232. And square root of 232 is 15.2, approximately 15.2. Okay, now that we know the diagonal of the pyramid, from this point down here, with this line like this, and this line like this, will help us to get the height of this pyramid. Let's call the height x. So x squared will be this side, which is 22 right here, 22 square, plus this side, which is half of this 15.2. Half of 15.2 is that should be this 7.7 or so. 15.2 divided by 2. Yes, 7.7 plus 7.7 square. And 22 square is 484. 484 plus 7.7 square. 7.7 square is 59.3, approximately 59.3. Now 484 plus 59.3 is 543 rather 0.3. 543.3. 543.3. S will be square root of 5.3.3. Square root of 5.3.3 is 23.3. 23.3 is this line here. Okay, now that we know, no, that's not, it's x rather. It is vertical height of the pyramid. So now that we know the vertical height of the pyramid, we can calculate the height of the triangular faces. To get the height of the triangular faces, we change the marker to red. Now, if I draw a line from here to here, and then draw another one down here, this slanted line here is the height of the triangle here. And this triangle, let me call it right triangle, and this left triangle, left and right triangle are exactly the same. So let's get their height, which is this line here. Let me call it R, small letter r. R square, we work it here. R square is equal to this line here, which is half of 47 square, plus the height, which we just calculated, 15.2. Let me label it there. This is D. No, it's not D, it's X rather. D is the diagonal which we calculated earlier. So let's remove this. Let me call it X. Use the same color to avoid confusion. This is X, and X is this 23.3. So now we are trying to get this large height here, which forms the height of this triangle here. So that is 7 square. That is half of this. This base here is 7 square plus this X here, and X is 23.3 plus 23.3. Let me check back to my red color. So 7 square is 49. It's supposed to be square. 23.3 square is 543.3. 543.3. Now adding all together, you'll have plus 49, 592.3. 592.3. R will be square root of 592.3. 592.3. And square root of 592.3 is 24.3. 24.3. Okay, so that is the height of left and right triangle. To get the height of front and back triangle, I draw a line back there and drop another one to meet it. That will give us the height of the front and back triangle. And this line here is half of 6. We already know X. So front and back triangle, let me call this dotted line F. So F square is equal to S square, which is 23.3. 23.3 square plus this line that I painted here, which is half of 6. That is 3 square. 23.3 square is 543.3. 543.3 plus 9. 543.3 plus 9 is 552.3. 552.3. F will be square root of 552.3. And square root of 552.3 is 23.5. 23.5. Okay, we know the height of the triangular faces. We can now get the surface area of this pyramid. First of all, get the area of the rectangular base. So let's do that here. Area of base is equal to length times breadth. Since the base is a rectangle, the length is 14, the breadth is 6. So 14 times 6. 14 times 6 is 84. 84. That is the area of the base. Then area of left and right triangle will be 2 times half times base times height. These two can cancel these two. The base of the left and right triangle is 6 yards. The height is R here. And what was R? R is 24.3. So 6 times 24.3. 24.3 is 6 times 24.3 is 145.8. 145.8. And then area of front and back triangle again is 2 multiplied by half times base times height. These two can cancel these two. The base of front and back triangle is 14 yards. The height, we calculated it to be F here. So 14 times 23.5. 23.5. 14 times 23.5 is 329. 329, or what was their unit? Yard square. So we know the area of the rectangular base, the area of the front right and left triangle, the area of front and back triangle. Therefore, surface area of this pyramid will be rectangular base, which is 84, plus left and right triangle, which is 145.8, plus front and back, which is 329. Let's plug all of that into calculator. 145.8 plus 84. That is 558.8. So the surface area of this pyramid is 558.8 yard square. And that brings us to the end of this lesson on surface area of pyramid. I hope you found it useful. If you do, don't forget to subscribe to the channel and also hit the notification button so that you get notified whenever I release content like this. Thank you and God bless you.